A web server is a convenient way of displaying information, and the Raspberry Pi is a convenient tool for collecting information. So it's inevitable that you'll want to turn your Raspberry Pi into a web server. There is a really simple way to do this, and you don't even need to install any software. Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips. Raspbian comes with a built-in web server courtesy of Python. Without any extra programming or installation, it handles static web pages and JavaScript. It doesn't handle PHP or other server-side languages, and it doesn't support secure HTTP without extra work. But for a quick and dirty web server, it's great. One other note. I'm only going to show you how to expose this web server on your local network. In a later session, I'll show you how to expose your Raspberry Pi to the outside world. So here we go. First, create a directory containing some HTML. I've provided a sample directory in the exercise files folder. On the Raspberry Pi, open a terminal window. You'll need your IP address, and to get that, type in hostname -I. And this gives you a list of all of the IP addresses that are currently open. In my case, I have a wired IP address and a wireless IP address. I'll use the first one, which is 10.35.3.111. Now, cd to the directory containing that HTML. In my case, it's CD on the desktop, and it's a folder called Exercise Files, 03_08. And I can confirm that by typing in ls, which gives me the contents of that directory. Once I'm in that directory, I can start the Python server. To do that, I type in Python 3, and by the way, I'm using Python 3 instead of Python 2.7. -m, the name of the command, which is http.server, and then an instruction to bind that server to the address 10.35.3.111. I'll hit return to start that command, and you'll notice that the Python server returns a port number. In this case, it's port 8000. We'll use that here in just a second. On another computer on your network, point a browser at the IP address that you just had, which is in my case, http://10.35.3.111. Don't forget the port number, which in my case is 8000. I'll hit return. And what I see is the web page being served by the Raspberry Pi. You can see the several pages linked to the original page, including slide 1, and something called GPIO status. Now, if you want to display system data from the Raspberry Pi, such as the status of GPIO pins, you'll need to create a background process that updates a static web page. Let's go back to the Raspberry Pi and I'll show you how to do that. Now, I've provided a simple example in the exercise files for a script that will do this. To run it, open a terminal window on the Raspberry Pi, cd to the exercise files, in my case desktop, exercise files, 03_08, and we're looking for a file called write_gpio_status.sh. So I'll type in /_GPIO_status.sh, and the / indicates that it's in this directory, but it's a command. When I hit return, this will update a static document for me. Now if I return back to our web page, and I click on the GPIO status page, it displays the contents of that static page that's being generated by write_GPIO status. We can update that, and you'll notice that the time changes, indicating that this is, in fact, the current status of all the GPIO pins on the Raspberry Pi. When you're done with the Raspberry Pi web server, just simply close the terminal window. Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.